Thanks for joining me on Med School Radio, where we think about topics we're likely to see on the USMLE. Okay, let's talk about gigantism. Getting very big, the bones are getting very long. Why does this happen? What hormones are necessary in order to make this happen? So the two hormones that are necessary are, of course, growth hormone, and the other one is, can you guess it? It is IGF-1, which is insulin growth factor 1. Now, do you know where insulin growth factor 1 is produced? It's produced in the liver. So first we're going to see, now this is before the growth plates are formed. If there is some form of hyperthyroidism, and we are seeing that there is too much growth hormone that is secreted. So this growth hormone is secreted before the epiphyseal growth plates are completely formed. This is why it's forming gigantism. You're going to see a lot of growth. So what happens is the growth hormone is sent out, and then there is a message which is sent to the liver. And in the liver, there is a pathway that will end up producing this insulin growth factor 1. Now, insulin growth factor 1 is what results in, this is what makes the cartilage and soft tissue and the bone grow. So you need both of these to work. Now, the pathway in the liver is called the Jak-Stat signaling pathway. So how does this happen? So the growth hormone comes down and it arrives at the liver and says, I'd like to make IGF-1. So it's met by Jak and Stat. So Jak says hi, and growth hormone comes in, and then they meet Stat. And Stat is dimerized. What does that mean? It means that it's doubled, really, and then it comes into the nucleus, and there is an increase in IGF production. Of course, it's much more complicated than that, but that's the idea here, that first you have growth hormone, then IGF-1 is produced by the liver, which results in the growth and development of the bone and cartilage and soft tissue. And if this happens before the epiphyseal growth plates are formed, it's going to form gigantism. And then this process may be finished, and you're not going to really see any more problems with this person who is presenting. They're going to present with normal serum TSH levels, although there could be some problems. Maybe there's something that may be seen. There may be some additional features. Maybe they will have some weight gain, or they may, be very sweaty. Things like that may be seen. So the main point that you need to remember is that you're going to see a person that is presenting with this sort of hyperthyroidism features. Like I was saying, they may be, they may have excessive sweating, and they may have, if you think about the jaw, the large jaw, some other things you might see. So this is acromegaly, obviously. If you remember from your system-based module, you understand the features of acromegaly. But the main thing I want you to remember from here is that if this growth hormone and IGF-1 is formed before and sent out before the epiphyseal growth plates stop growing, you're going to have gigantism. And it could actually end there. And what you're going to see is a person with some very long extremities, but, the TSH levels would probably be normal. So thanks for tuning in, and try to remember those major points. This is Med School Radio. Hello everyone. Today let's think about the process by which glucose enters a pancreatic beta cell in order to promote the release of insulin. How does that happen? What is the mechanism? So first understand that glucose enters the pancreatic beta cell through the GLUT2 receptor, and then with the enzyme glucokinase, glucose 6-phosphate becomes pyruvate and then enters the TCA cycle. Then ATP is produced, and then there is closure of the potassium channel, which then results in an increase in calcium, which then allows insulin to be released outside of the beta cell. And I know that sounds very scary, but it's actually a very simple process, and this is something you would need to know to understand what's happening in gestational diabetes. So when the mother is not producing insulin, why is this happening? So you might be asked a question about some genetic predisposition and what is breaking down in this system. So it could be, for example, a problem with glucokinase. So if that enzyme is deficient, then glucose is going to have a problem right from the beginning coming through that GLUT2 receptor, and nothing's going to happen. That pathway is not going to happen, and insulin is not going to be released in response to glucose. And that is a very simple explanation of what might happen when your patient is genetically disposed to gestational diabetes.